I call this video the silt meter because it describes an experiment designed to measure the visible impurities in a sample of water. And here is my water contained in this plastic box. I've got exactly 500 grams of water in there. On one side I have a small bulb, which if I turn on the power supply, you can see will light up. The light shines through the water and is detected by a light-dependent resistor here, and the light-dependent resistor is connected to a multimeter set to a resistance range with a maximum of 20,000 ohms. Now, for my impurity, I'm going to use milk, and I'm going to put this in small droplets. I've already measured the mass of one droplet by measuring a large number of drops and calculating the mass of one, and so one droplet is 0.3 of a gram. So the original reading of clear water, will be better put the top on to cover up the box to exclude any other visible light. Well, it's about 11.4 K, so yeah, 11.4 K. So that's with no milk in it at all. Right, let's put the first drop in, just to take out, I know roughly how much milk I want to put in. Here's the first drop, and we'll give it a little stir, make sure it's mixed up properly, and put the top back on. Now, the reading's gone up, you see, to about 12.3. And that's with one drop. Put another drop in. That's 2 drops. Give it a stir and cover the top. Now it's gone up to 14. It's settled down. The milk and water are moving probably a bit, so 13.9 I think probably. Third drop. Now I'm trying to make the drops all approximately the same mass. So that's drop 3. Stir. Cover. Just under 15, so I think 14.8 K. Another drop. This is drop 4. Another stir. And the reading there is just 15.5 I think. Now I'm trying to add the drops in equal sizes, and remember each drop has an approximate mass of 0.3 of a gram. Right, that's drop 5. I'm trying to get at least 6 drops because I'm going to plot a calibration graph for this, and it's useful to have at least 6 readings. Right, 16.3 almost, and drop 6. Stir it up. And 6 is 17.2. I'm trying to get readings in the center of the variation. Now, I can go on adding some more drops, and I'm going to go on until I've got 10 drops in there, but I'm going to stop the video now, make the other measurements, and then we'll come back later and work out some results and look at the calibration graph. Well, as you can see, I've now taken some more readings to enable us to plot a calibration graph for the system. And I've plotted the LDR resistance on the y-axis against the mass of milk added on the x-axis. What I'm now going to do is to look at a mixture of milk and water where we don't know how much milk I've added, and we'll use our calibration graph to find out how much milk has been put in. So there's the setup, and I've adjusted the bulb's position slightly so that the resting position, the starting position with clear water is the same as it was before, because the light levels in the room have changed a little bit. And I'm now going to simply add some milk. I've no idea how much I'm adding, but we'll take that amount and find out how much milk has been added to that amount of water, because I have taken exactly the same amount of water as we did before. Now we need to give it time to settle down. We must of course put the lid on the box to cut out all the unwanted light. Just check that that's fitting over all the way around properly. Right. Now let's just wait for a moment for this one, and we are going to make sure that the readings have settled down to as near as we can anyway. And I think that 17.8 will be a reasonable reading. Okay, 17.8, fractionally under 17.8. Okay, now let's have a look at our calibration graph and see how much milk that actually is. Well, the resistance of my LDR is 17.8K, and let's have a look along. Well, 17.8 is here, that line, there's 18, each of the divisions are 0.2 of a K, so 17.8 is there, which means according to us we've added just under 2 grams of milk. So let's see, that's 1.9, about 1.97 grams, but certainly between 1.9 and 2 grams of milk into that unknown solution. So a useful experiment, and it is indeed a silt meter because it measures this unknown concentration.